Hello, class. Today we'll be talking about Chapter 11. We'll be talking about counting methods and probability theory. So, in 11.1, we'll be talking about the fundamental counting principle. And entailed in this, some objectives for today, we'll use the fundamental counting principle to determine the number of possible outcomes in a given situation. So, first thing we have is a definition. So, if you can choose one item from a group of M items and a second item from a group of N items, then the total number of two item choices would be M times N. So if we look at this tree diagram, let's say if we had two pair of pants and three shirts. Now, to figure out how many different two two item choices we would have what? 2 times 3, which gives us 6. So you have a total of 6 different outfits that you could possibly make from 2 pairs of pants and 3 shirts. Because every shirt can go with 1 pair of pants, and every shirt can go with another pair of pants. So it gives you a total of 6 different 2 item choices that you can actually have. So you just take the number of choices in one and multiply it by the number of choices in the other, and that's how you get it. Get your answer. So, example, the Greasy Spoon restaurant offers 6 appetizers and 14 main courses. In how many ways can a person order a 2-course meal? So we have 2 things to choose from. We have a what? An appetizer and main course. So, just like we know from the definition, we have what? M times N. So it'd be what? 6 times 14, which that equals 84 ways. So it's 84 different 2-course meals that they can actually have. So 84 different 2-course meals. So 84 different 2-course meals. Because we have what? 6 appetizers and 14 main courses. Now let's say if we had multiple of these things. So you're doing the same exact thing, but what are you doing? You're multiplying by multiple different groups. All right? And this is what the definition says. The number of ways in which a series of successive things can occur is found by multiplying the number of ways of which each thing can occur. So let's say if I had 2 pair of pants, 3 shirts, and 2 pairs of shoes. Now we have another additive. I have what? 2 shirts, 2 pants, 3 shirts, and 2 pairs of shoes. So it'll be 2 times 3 times 2, which gives us what? 12. So basically you're doing the same exact thing, but you just have multiple different things that you can use. So keep that in mind. So let's look at an actual problem when we're using this. So it says, next semester you're planning to take 3 courses: math, English, and humanities. There are 8 sections of math, 5 sections of English, and 4 humanities that 4 sections of humanities that you find suitable. Assuming no scheduling conflicts, how many different 3-course schedules are possible? So, since we already know that we have what? 8 sections of math, then we have 5 sections of English, and then we have what? 4 sections of humanities. So when we go through this and we actually multiply this throughout, we get what? We get 5 times 8, which gives me what? It gives me 40. So 40 times 4 gives me what? 160. So it's 160 different ways that you can make your schedule. So keep that in mind when you're doing these problems. Now, let's look at something a little bit more that's going to make you think a little bit. So you're taking a multiple choice test that has 10 questions. All right? Each of the questions have 4 answer choices, which one correct answer per question, right? If you select one of these 4 choices for each question and leave nothing blank, in how many ways can you answer the question? So let's look at this. Now, the first thing you need to think about is we have what? We have 10 questions. Now, but each question has what? 4 answer choices. Now, using the fundamental counting principle, we need to do what? Multiply all these things. So this is really just 4 to the what? 10th. And that equals, when you put in your calculator, 1,048,576. So make sure you understand what you're actually being asked. Because there are 4 actual choices for each what? Question. And each one could possibly be one. So when you're doing this, make sure you sit down. And you notice I wrote dashes. It's just basically to say that for each question, I had what? 4 answer choices. Let's look at this question. So it says what? Telephone numbers in United States begin with 3 digits, area codes, and followed by 7-digit local numbers. Area codes and local numbers cannot begin with 0 or 1. How many different telephone numbers are possible? So let's go ahead and write this out. Now, if you notice, these dashes are just the numbers, the ones that separates the digits. All right, your area code and your local numbers. So we know it can't be 0 or 1 for the first digit in the area code or the local number. But so now from 0 to 9, there are what? 10 numbers. Since it can't be 0 or 1, we know that the first digit has 8 different ways, 8 different choices, because you took away 2 of them. Same for here. It's 8 different digits that we can use. We're not saying that digit is 8. We're saying it's 8 different digits that can be used. Now, for the rest of them, it could be anything. It could be 0 through 10. All these 10s you see me writing are the 10 different ways or 10 different digits that I can actually have at that spot. So now, using the fundamental counting principle, all right, I'm going to get 64 times 10 raised to the what? Eighth, right? Because it's a 10-digit number, right? It's a 10-digit number, and we have what? Two of the digits can't be 0 or 1, so we got 8, which is 8 times 8, which is 64. So it's 64 times 10 to the 8th. Then you should get what? So you should get 6, 4, 0, 0. Then we have 6 zeros behind it. So it's 6,400,000,000. Now, make sure if you have any questions about this, you make sure you ask me. Now, remember, the quickest way to get in touch is to go through Microsoft Teams. Now, if you're having issues with Microsoft Teams, shoot me an email. I will respond. All right, so if you have any questions about this section, make sure you send me a message.